Hi, this is Chris Hughes, graduate student at the Institute for Interactive Technology at the University of Alabama, and I'm going to give you a quick overview of some research studies on virtual worlds in the field of higher education. After playing with Second Life and visiting some of the college and university campuses there, I was interested to see if anyone was actually having success teaching in a full virtual environment. It seems to me there are few subjects that lend themselves to being taught effectively in a fully virtual world. Sociological and economic issues can be easily observed within a virtual society, so a research-based course in one of those subjects may have some success. But creating a more traditional learning environment inside a virtual world seems like it would be tricky. After some digging through the research, it seems at least a few educational experimenters were having some success teaching computer programming concepts in the virtual worlds of Second Life. Computer programming seems like a near-perfect topic to teach within an environment such as Second Life. A programming language and various development tools are built right into the system. Second Life allows users to develop in-world objects with custom properties and behaviors. All of these objects are persistent in the world and can interact with other users and objects within the Second Life universe. I think the environment is best explained with a quick demo. Okay, so now I'm going to just hop into the Second Life environment and show you what I'm talking about when I describe this interactive, immersive environment for programming in Second Life. So I'm going to right-click on the ground here and choose Build. I'm going to select an object type and then click on the ground again to place that object. And here I've just placed a cube on the ground. I can change some parameters of this object, such as I'm going to convert it to a sphere. I can use these tick boxes here to change the size of the object in 3 dimensions. So I'm going to expand this in all 3 dimensions, and then I'm going to rotate it around the x-axis just a little bit, just to kind of show you what's going on here. But where it really gets interesting is you can create scripts that will let you do just about anything within the Second Life world. What I'm going to do here is set a command to just change the color of this object that I've created. So I'm going to set the color code for black, and I want to apply that to all sides of this object. When I click the Save button, it's going to make a round trip to the server, and then you'll see that my object has indeed changed to black. I'm going to change the color code to green here and save again. And then fairly quickly you see that I'm looking at a green sphere on the ground instead of a black sphere. Now I'm going to zoom in here to look at the object up close, and you can see it looks pretty much like a big green watermelon. That's the very basics of scripting within Second Life. Now back to the research. 2 of the biggest problems with current methods of teaching computer programming are the mismatch between the passive lecture environment and the active process of writing code, and the difficulty students experience with the abstract concepts involved in problem solving within a computer language. In a 15-month study beginning in 2007, Michaela Estevez, Benjamin Fonseca, Leonel Morgado, and Paulo Martins worked with several first and second-year students in information technology programs in Portugal to see if there was a solution to these 2 problems to be found within a virtual world. Most of the students in the course had taken at least 1 semester of a high-level programming language, so they had some experience with computer languages in the traditional classroom environment. The programming course was taught entirely within the Second Life environment, meaning all course materials and student-teacher interaction took place within the virtual world. Students worked in groups to develop an in-world project of their own choosing and were expected to work together to develop their programming projects all within the tools provided by Second Life. Because all of the groups worked in the same location, all of the projects were developed in the open, in full view of the other groups. Working in an open environment had a bearing on the quality of work being done by some of the groups. A key factor in developing code in Second Life is depending on what kind of code you're working on, you get immediate visual feedback on your work. This shortens the feedback loop between writing code and seeing the results, and supports other research suggesting the use of animation displaying program execution helps minimize student difficulties in grasping abstract concepts. Students working on non-visual projects struggled both with the concepts of computer programming and with the apparent mismatch between project and environment. According to Estevez, we verified that using a non-visual project did not have a good impact on the students' performance because they were focused primarily on non-visible techniques. In addition, the students did not learn properly and struggled with themselves, not understanding why they had to do such a kind of project inside this environment. The researchers found that students working on visual projects within a virtual world had a much higher rate of success. The students had an obvious feedback regarding the correctness of their program. Obviously, when something goes wrong in a visual environment, it looks wrong, and precisely how it looks wrong can give clues to the source of the problem. The implications of this research are not limited to the confines of a virtual world. In this case, social learning was an important factor in how students completed their projects. Some student groups continued to develop their projects outside of class and even created other programs in the Second Life world just to show off their skills to the teacher and other students. These findings are supported by the 2009 work of Nicole Cargill-Kipar, who conducted observational research on another programming course conducted within Second Life, and states within the Second Life environment that learners were motivated by being able to see their peers work. The difference in learning between the groups with visual versus non-visual projects suggests the importance of matching the learning experience to both the learning environment and the learner. Cargill-Kipar sums this up by stating, "The module was successful in terms of student learning and engagement. Most learners who have voiced initial concerns over Second Life realized its potential for programming." This means that no matter what the environment, we have to learn how to engage and inspire our students. According to Albert Einstein, a society's competitive advantage will come not from how well its schools teach the multiplication and periodic tables, but from how well they stimulate imagination and creativity. This presentation is just a small window into what is going on in higher education inside virtual worlds. Many schools have a presence in Second Life and are still feeling out the boundaries of the learning experience there. Only time will tell how these interactive environments will be used in the future of our education. This is Chris Hughes at the Institute for Interactive Technology at the University of Alabama. Thanks for listening.